Bow our heads in prayer, shall we? Our dear Heavenly Father, we have been told in your letter to us that we are fearfully and wonderfully made. And it's really amazing that with so many different parts of our body that have to work in perfect harmony for anything to happen, that we see how true that is, that we truly are fearfully and wonderfully made. Help us to understand some more about the wonderful things that you have made for us, and also the different flavors and things that you gave to us so we could enjoy eating so much. We thank you that you didn't just make it so that we had to take some tasteless pills to get our energy, but that we could enjoy the foods that we eat so much. And in the future, help us to choose the things that you gave us originally so that we could have the optimum health that we so much desire. We thank you in your holy name. Amen. Now, first of all, we need to take you back to either middle school or maybe before that. And what did you hear about chlorophyll and sunlight? Okay, so we know that CO2, which is in the air, and water, those will go into a green plant, which has chlorophyll in it. And when sunlight hits that, and that plant then will start making, if it's a food plant for us, it will start making food, which we use for energy and which we use for health. Okay, so there's two things that we eat primarily, and that is sugar and fat, and they're made from these two things, all right? Now, what happens when we burn sugar and we burn fat? Is that we lose weight? Okay, that was a good answer. I see somebody's interested. Okay, but there's something that's quite important for us to understand here. And the way we get rid of the waste products is, what is this here that we've drawn? Those are our lungs. And so when this is burned, we have sugar and we have fat, and the waste products turns out to be what? And those are the things that so we started out with CO2 and water, and we've ended up, we had sugar and fat, we burned it in our bodies. These are the energies. The cleanest energy is sugar. Fat can give us something that we call ketones, so it doesn't burn as clean. So sugar is the most important thing that we need to have. And then fat can be used also. When the sugar plays out, we can convert the fat into sugar and burn that as well. Okay, so when we burn it, we go back to CO2 and water. And when we breathe in, we've got oxygen, which helps us to burn the sugar and the fat. And we breathe out CO2 and water. Did you know that every time you breathe out water as well? Yeah, but the thing that we're really trying to get rid of is carbon dioxide. Now, it wasn't until about 1820 that they said, wait a minute. There's something when we have a food and it's greasy, and if we put it in water, it floats to the top. And then there's something that's sweet, but when we burn this food, we realized that if we separated these out and found out how much fat and sugar there was in it, there was still some other calories. And they said, what are these other calories? What's different about these? Because they don't fit into either one of these categories. And that's what we're going to talk about tonight. And what is the third nutrient that we eat? Okay? We have now what is different with this one than from these two? Okay, I'll give you a hint. The one of the letters here in this word is the word that I'm looking for. The element and the atomic symbol for that is in this word. And I'll give you another hint since I didn't hear the answer. It's very near the end of the word. Nitrogen, very good. You can move to the front row. Okay, so the nitrogen. Now, when we have this nitrogen, when it's burned up, we also burn up the carbon, and those are calories as well. If you eat too much protein, it can just give you too many calories, and that could make you fat as well. But the nitrogen is another thing. It's different. And in what way is it different? Okay, nitrogen has to have something else in order to get the waste products out. What is that? That's your kidneys. Okay, so the blood goes through the kidneys about 120 cc's or 120 milliliters a minute, and it takes the sugar out of the blood and the salts out of the blood, and it keeps the blood in really good balance, but it doesn't try to keep all the waste products. And you saw that on your blood work that you got today. And there was one, somebody said, what's the bun anyway? Well, it's blood, urea, nitrogen, and that's this nitrogen, okay? Now the nitrogen is a negative ion. It's called urea. And so when it goes out, it has to take something positive with it. And so what might it take with it? Well, one of the things that we're worried about is it's going to be hooked on to a calcium, and that's a positive ion, and then those two will go out. So if you're eating too much protein, then what is going to happen to your calcium? It goes out with it. Now you see the part of your handout that's there? It's Physicians Committee for Responsible Medicine. Okay, when you see that, you'll see I've highlighted 2 spots on that. And what does it say on those? Well, I'll tell you. It says that when we drink those 3 servings of milk or 3 glasses of milk, or however we get it, that is not a good plan to get our calcium from milk. Why? Because the milk has too much protein, and it's going to take the calcium away from it. So what does it say on the second one that's highlighted there?
It's useless against osteoporosis.
Milk is useless against trying to fight against osteoporosis. Osteoporosis is thinning of the bones. Okay, so this is just kind of an introduction. And now I'm going to, if you folks can see this, I'm going to bring this down lower. And we have something called amino acids. And these are the building blocks for our proteins. Okay, amino acids are 8 essential. And altogether there's 20 plus of these. So what are the other 12 for if only 8 of them are essential? Well, they're all essential. But why we say essential is that you must eat these kind of amino acids, and the body is so good, the liver can take these 8 and it can chop a little bit here and add on there, and it can make the other 12. Now, originally, they thought that we should have 1 gram of protein for 1 pound. Okay? Then they decided, well, probably that's too much. This is in 1860 that they found out that we had protein. They didn't even know what it was before that. So it's been fairly recent, hasn't it? Okay? So they said 1 gram. Now, what is a gram? Well, if you had an American nickel and you had it in your hand, that would be almost exactly 5 grams. So you can see it's not a whole lot, is it? But they're talking about the protein that you need. So that would be one of these protein molecules. Now you need to have, how many of those? They said you needed to have 1 gram per 1 pound. And they said, no, that's way too much. They said, let's have 1 gram per 1 kilogram. Now a kilogram is more than 2 pounds. So that means that they decided that you needed less, right? So they said, well, let's tell people that they need to have 120 grams of protein. Now, if we do some higher mathematics and we multiply that out, how big of a person is that amount of protein for? Pardon?
240 plus?
Yeah, it's more than 240. Okay, so that means that they're giving enough protein for all the Americans. They're telling all the adult Americans that you need to eat enough protein for about 260 pounds. Now, some people are that size. Hopefully, Americans haven't all gotten to that size. When they do, that'll be the end of the Americans. Okay, so we as Americans, though, unfortunately, we haven't done ourselves a favor, because since 1970, the average male has gained 25 pounds, and the average female has gained 17 pounds. And so that's the problem. And then we're going to see tonight, when we talk about the metabolic syndrome, that when people get that syndrome, then that's going to take out our middle school and our high school students, and we'll talk about that tonight. Metabolic syndrome is going to be the #1 killer in the United States. It's going to even surpass cigarette smoking is the biggest killer in the United States. Okay, well, let's go on with this. Well, what is it actually then? Well, when I was in medical school, our nutritionist, who is one of the best in the United States, said what they found out, that it was actually 1 gram of protein for only 1/3 of a kilogram of body weight. So you can see that's a whole lot less. And so what is it just in terms of what you need to keep in mind if you're trying to tell somebody? And we would say that that's probably about 25 to 40 grams of protein is proper for the average adult, depending on their size, depending upon how active they are, depending on if they need more protein because they're protein malnourished, or for other reasons. Now, on the other side there, I've tried to make the point, and this is the most important point probably, that you can understand from this talk, and that is, if you're eating a wide variety of food, enough so that you're not losing weight unless you need to, if you're eating a variety of different foods, it is impossible for you to get protein malnourished on a vegan, pure, plant-based diet. That's the number one thing I want you to get from this talk. Now you're going to go to maybe the average nutritionist or the average registered dietitian or some of the other people that work in this area, and they're going to give you the idea that you can't get enough complete protein if you only eat plant-based foods. Have any of you heard of that?
Yes.
Why did they tell you that?
There's some meat.
Because that's what they actually believe. Now, give me a little bit of time here, and I need to clean this board off because there's some more concepts we need to have right away so we can understand what we're talking about. Now, have you folks all heard of amino acids? Okay, those are the building blocks of our proteins. We don't know everything there is to know about the human body or chemistry or anything else in nature, but it's been estimated that there are probably 100,000 different proteins. Proteins do a couple of things. The albumin is what's circulating in your blood. And if you looked at it, it probably said that your total protein was around 6, and your albumin was around 4, and something else, it sounds kind of like a strange name, and that's globulin. Albumin is the way that the building blocks, the amino acids, it's circulating in your blood. And these are always ready for you to take some and to use them in your cells and to build tissue or to repair whatever gets broken down, and so that's how that works. Now the globulins do something else. They carry. They carry things around, and they also have to do with your immunity. Now, some of you may have heard of IgG and IgM and IgE. Have you heard of these globulins? Well, those are things that we measure to see how your immune system is working. And it's so terribly complicated that we don't really understand all of it. But we're trying to understand as much as we can, because when we understand more, we can help more people that have problems. So a carrier is called a globulin, and all of you can think of a globulin that carries something. And if you can't, you'll say, oh yes, of course, I knew what that was. Can anyone help us with that? What's a globulin that carries something?
Red blood cell?
And what is it called?
Plasma?
It's called hemoglobin. Okay? But we don't have things that are just circulating around just free. They're usually connected. Your hormones and everything is connected to some kind of a carrier protein. Okay? And so keep that in mind. And it's a very intricate thing, and it's a very wonderful thing, the way these things can be separated and brought into the cell. Okay, so let's look at the albumin here. And I'm not going to, the PowerPoint is going to give you a better picture of it. But what I want you to get out of this, and this is schematic. These are some of the different globulins, and I'm not drawing them in any particular order. But some of these globulins that are very high in the animal products, we will find that they will come in a ratio that we don't need. In other words, there'll be too many. And so say this is one of them that has too much that the body doesn't need. And so it just keeps getting more and more of this built up in here. And there's no place to store these. They have to all fit into the albumin. And so what happens to these is that they have to be chopped up. And the nitrogen, like we said, the nitrogen has to go out. The extra nitrogen has to go out through the kidney. We can't blow it out of our lungs like the CO2 we can. And also, when it goes out, it's going to take, what do we say was going to go out with it? The calcium. Calcium is a positive ion and nitrogen is a negative. And that's the reason why, if we're trying to get our 3 servings of milk a day, we've got all of these amino acids building up that the body doesn't need to build the proteins that we're repairing in our bodies, okay? So these all have to be chopped up, so that's extra work for the kidneys. Now this is a very important concept. When we take the plant-based proteins, it's a lower protein, so that means that there's going to be less of this stuff that has to go through the kidneys, right? Less waste products in a lower protein diet. But also the plant proteins are in the ratios that our bodies are going to need more frequently. And so we don't have all this buildup. And so that's the reason why sometimes people come in here and their kidneys are going bad on them. And we find out that they're not getting rid of the waste products the way they should. They're not filtering the way they should. And so what happens, then they say, you are getting into an area where it's dangerous for you. We're going to have to take an artery in your arm, and we're going to have to take a vein, and we're going to have to hook those together. And in about 3 months, the veins in your arm are going to be about the size of your little finger, because now you're going to need to go on hemodialysis. And so we'll take a large needle and we'll put it into one of the veins, and we'll take another large needle and we'll put it into another of the veins, and we need to cleanse your blood through this machine over here. And we call that hemodialysis. You know, in the 25 years that I've been here, I wish I could have followed all the patients, but many of the patients that already had the shunt put in their arm, they never had to use it, at least while we were following them. Why? Because their kidneys were healthier, the proteins were the right amount, and they weren't getting an excess amount. Now, if you know anybody that's on dialysis, dialysis is more like a sentence than a life. Do any of you know of anyone on dialysis? Okay, and so you know what I'm talking about. And that alone is something that's really, really worthwhile to come here, especially most of the people that go on dialysis in the United States are people that have damage to their kidneys because of diabetes. Okay? Now, when we understand this, it's going to help us to understand the video that is there. Does this thing take off? Okay. Okay, now here's something else that I really need to tell you. As I said, that a person who is eating a balanced diet, enough calories from only a plant source, they cannot get protein malnourished. Before we had dialysis, there was a Dr. Giovanetti, and he decided, I don't like the idea that my patients are getting more and more of the, we call it uremia, more and more of the protein waste products building up in their blood. And so they will go into a coma and they'll get slower and slower and slower until they're in a coma and they'll just be lying there. He said, what I'm going to do is I'm going to give them a diet that is so low in protein that they're not going to go into that coma. So he did that. He tried his very hardest, and he found out that practically all he could give them was refined pasta and butter balls. Otherwise, just about everything else had too much protein in it. Well, the people did become protein malnourished, and they did die, but at least they had a longer life when they were still aware of what was going around them. And so that's what he did before there was dialysis. And so it's very, very hard to get a person into a negative nitrogen balance. The other thing is that there are people that have a negative nitrogen balance, and what would those people be? What group of people would those be? Well, they would be people that weren't eating, right? Is there such a thing as people that don't eat? Yeah, especially our young girls that think that they need to look like Barbie dolls. And if they're really into that, they might do an excessive amount of exercise and then keep restricting their diet and restricting their diet until they become protein malnourished. And that's a big problem. What else? Who else? What other group of people could become protein malnourished? I've seen a few. We've even had people here that have been here on this campus that were protein malnourished. Why was that? Because they thought that they were sensitive or allergic to almost all their foods. And they ended up by, the two that I was most closely associated with, they ended up by eating wild rice, which has almost no carbohydrates in it, and eating organically grown snowpack peas. That was the two that I was the most closely associated with. And those people really, really got protein malnourished, and they were very, very sick. A woman that was probably about 5'4", I don't know what she weighed, probably 70 pounds. There was a man that was 6'2", and he weighed 110 pounds. So that's the thing that you don't want to do. You never want to get into a state like that where you say, well, you know, I find that beans give me gas. Yes. You noticed that, did you? So I won't eat beans. Well, I find out that the tomatoes and the nightshades, well, I hear they're bad for your joints, so I gave up on those. And then I thought that potatoes had too high a glycemic index, so I gave up on those. And you can see they keep giving themselves an elimination diet until they can't be healthy. And then there's another group, unfortunately it's not a big group, but people that are on cancer therapies and stuff, they can get protein malnourished. But those should be very special situations. They shouldn't be something that we see all the time. No, they would eventually have problems if it was just fruit. If they considered the nuts as part of the fruit and because the definition of a fruit is the ripened ovary of a flower, and actually vegetables are only the green leafies and the tubers, things that grow underground and the green leafies. So if it was a true definition of a fruit, then they'd be eating fruits and grains and legumes and nuts. But anyway, that's a whole different thing. Now let's take a look at this. Okay, so this is the protein story. And how's your self-diagnosis coming? It's not recommended, okay? You can find out that you've got all kinds of things which you really don't have because you think, well, I'm sure that I have that symptom. I remember my roommate in medical school, and I don't know whether he was having me on or what, but when we were studying cancer, he says, Lukens, I've got cancer. When we were studying parasites, he said, I think I have parasites. So if you get on the internet and you really try to read everything about the disease that you think you have, you are really going to make yourself bonkers. You're going to narrow your life, and you're going to have, you just won't have a very happy life. Anyway, enough said about that. The tests show that you're developing an ulcer trying to figure out your health insurance coverage. This is a very old cartoon. Now it's worse, right? Okay. I think I missed a slide. Let me go back. No, I didn't. Okay, now this is something that's different. This is saturated fat. And here's another reason. Most of our saturated fat comes from milk, and I'm not going to belabor the point. The second comes from beef. And I threw this in here because I wanted you to see very quickly what's going on here. Arterial function deteriorates on Atkins diet. Down there it says the meat-heavy Atkins diet increases both HDL and LDL cholesterol. And we'll look at that later. There's two things that the United States Department of Agriculture lets us advertise in a different way. One of them is milk. Milk is advertised by volume, and beef is advertised by weight. Now, what would you consider to be a healthy food? Remember, on the calendar that I gave you, it says that we want you to eat less than 20% of your calories from fat. Remember that? Well, here, extra lean ground beef chuck, 80% lean, 20% fat. That looks like a health food. But they're doing it by weight. And we can't go into it all together, but this is the biggest source of the pathogenic E. coli. There's 0% truth in this because sometimes the 80 and 85% lean is not what it is. It'd be illegal for any other food, but beef can be advertised that way and so forth. We could look at that at another time. But I want you to, this is just by way of introduction, but I want you to see the reason why we're promoting the two foods that most of the people around the world are going to eat. And they're going to be eating a grain and they're going to be eating a legume. And you can think about different ones. Where we were in Africa, the people ate in a different way. They fixed their food different, but they were eating mostly corn and beans, like the people in Mexico do, and in other places in Central and South America. If you look at the people in Asia, they're eating rice and soybeans. Okay, most people that are up in the hinterland, and they're some of the healthiest people. That was a China study. Very few diseases that we have as Americans. What did they usually die from? Infectious and communicable diseases and medical emergencies. So they died like we did at the change of the last century between 18 and 1900. Okay, so now, what about the fat? Well, we've got protein here. Remember we said that it was a low protein diet, but not a diet that was too low in protein. It was a low fat diet, not too low in fat, and then the rest was what? But you've got to say it right. It was complex carbohydrates or unrefined. Next lecture on diabetic syndrome. Remember this one because this is huge. This is very, very, very huge. Okay? Now, if we look at the 80% lean, we see the first time the Atkins diet came around, it was called what? The high protein diet. The diet for the new revolution. Okay? And then, now the second time it came around, what does it come around as? Everybody say it in unison. You all know it. It's the low carbohydrate diet. Now, I know we've got to hurry through this, but I've got to make some points here. There were 4 major diets that were studied in the United States. Big study. And which one caused the fastest and the most weight loss of all the diets? Atkins. Atkins was faster and more weight loss than the low fat and the low carb and some of these other diets. And so his was low carb too, but there were 4 different ones that they followed. And so now I can't show you, but lean meat, ground beef chuck is very, very low in carbohydrates. So if I were to put the carbohydrate on this, there would be a little tiny sliver at the top, which is about 2 or 3%. So when you're eating the Atkins diet, it is truly low carbohydrate. You can't get it any lower. And Dr. Atkins, and we'll talk about this when we talk about hypertension, but very briefly, a man came on and he said, this is a cardiologist. They did a PET scan, and we'll see that later. And it showed they followed 11 people that were on, that they really truly were on the Atkins diet. And at the end of the year, they all had problems with not enough oxygen to their heart. Dr. Atkins came on, and he kind of basically called the cardiologist a liar. The cardiologist didn't say anything. You can't lie about a PET scan. But anyway, he said, I have 65,000 patients. Now, he didn't, but maybe he's following him with other doctors. And he said, I know that when people are on my diet, it's a very, very good diet. Their cholesterol goes down, and their diabetes is under better control, and their blood pressure goes down. He said, how can you argue with that? Is that true? Is that true that all 3 of those things happen? It's absolutely true. Why? Why is it true? Because of the weight loss. But what he didn't say was that this is very, very good. All these numbers are coming into line, but you're killing yourself. He didn't say that. If, however, you'll see tonight when we talk about the metabolic syndrome, if he had said you should eat a lot of carbohydrates, but make sure that they're not refined carbohydrates, then he'd have done the whole world a service. This low carbohydrate diet has gone right around the world, especially in the Western type people. Okay, let's hurry on now. Oh, to be quite honest with you, it isn't worth fixing. You know, you bring your car in and the mechanic looks at it and he laughs. Well, now the mechanic comes in, he looks at the doctor, and the doctor gives him the same message. I'm trying to cut back on those things. They're loaded with fat. Okay, now, we've already talked about this, and we can't go into it because our time is going. But this is something that's being carried by, this is only part, it's only 1/4 of the carrying part of this molecule. And what do you think that molecule might be? That's an iron molecule, okay? And when your blood goes back in, it's about the color of these chairs here. You saw it when they drew it. And what color is it normally after it's been oxygenated? It's about the color of her shirt. Bright, bright red. Okay? Now there's a test to see how well a person is controlling their diabetes. And it's called the hemoglobin, glycosylated hemoglobin, and the one that stood the test of the time is the A1C fragment, or the A1C fraction of that. And what happens is that when there's a high blood sugar, it binds onto this iron, and it's like carbon monoxide. It clutches onto it and it doesn't release it. And so we don't want very much of that circulating in our blood. And so we didn't know how to follow people. But now that's the gold standard, and it's really wonderful that we have that because we can see how well a person is in control for the last 3 months. Now here is a cell, and this is very, very, very simplistic, but it has some of the major parts in it. This is the nucleus, and from the nucleus we get the DNA and the RNA, and this area is the area that makes all these proteins. Okay? We have something that works on the fat metabolism, but also something that works on giving us energy, and these are called mitochondria, and we will talk about these tonight when we talk about Syndrome X and when we talk about exercise. But this is where the energy is, and it's a clean energy that we have if we're burning sugar in these cells, and these are called mitochondria. They look like this. And then this is one that's been cut along that way, and then this was one that's cut this way, and it shows the top half of it as well. So if you get the picture there, we're going to go down, and we're just going to take a slice of the cell membrane, and we're going to look at that. That's the cell wall or the cell membrane. And here we call it lipoprotein, and here we have this is the outer edge and the inner edge of the cell membrane, and then this is the fat that's in between there, and then we have cholesterol. We have a channel here that'll allow sugar or other types of nutrients to come into the cell. It's all very specific, okay? And then this is a receptor site. Now when a cell is fed up, the insulin receptor site goes down, and the insulin can't dock there, so that more sugar can't go into the cell, and we'll talk about that later. Now, we talk about, this says a cholesterol molecule. We talk about this LDL as being bad cholesterol. There isn't such a thing as bad cholesterol. It's just that if there's too much of it, and we'll see that when we talk about the hypertension lecture, if there's too much of it, then that's going to destroy the arteries and plug them up. So this is what we have here, and this is the reason why we want to realize that the cell is a unit and it only accepts into the cell the things that it needs. And that's the same way with the protein. If it doesn't need any protein, it won't let the albumin to come inside. Okay, here is the amino acid in eggs, and they all have their different names here. This is methionine, and this is cysteine. And then there's arginine and alanine. What's this big tall one here? That's glutamine. It's very, very high in wheat. Now, the reason why I'm showing you this is these are the amino acids. They're not all of them there, but these are some of the principal amino acids that are in the white of the egg. That's the albumin. Now, if we took and drew a red line across the top of the human albumin, this is the kind of a template, or this is the type of a pattern that we would get. Now I'm going to take the human albumin, and I'm going to take it, and I'm going to put it back on the egg albumin, and you can see that it's almost a perfect match. Why is it then that you shouldn't eat as many egg whites as you want to eat? Why couldn't you just say, have 12 egg whites in a day? What would be wrong with that? Because there's too much protein. In fact, that's what they're asking the people to do that are on dialysis. They want them to eat maybe 12 egg whites a day to get that protein way up there, you see, so that their body is getting enough protein. We find just the opposite is the thing that helps the body to be the healthiest. Okay, so what happens then, here's methionine. And if we get a lot of methionine from the animal products and we don't need it, then what are we going to have to do with it? We're going to have to cut it up, chop it up, and send the nitrogen waste down through the kidneys. But we do need methionine, and this is where I'm talking about vitamin B12, because methionine is one of those 8 essentials, and cysteine is what methionine can be turned into, and it can make the amino acid cysteine. Now, why do I tell you that? Because you have to have vitamin B12. Now, maybe this is too technical for a lot of you, or maybe for most of you, but when methionine is turning into cysteine, first of all, it becomes homocysteine. Has anybody heard the name homocysteine? Homocysteine is what rips out the inside of your arteries. It causes the lining to die out, and then that's why plaque starts building up. And so that's the reason why, and we'll talk about that later, you really, really have to supplement vitamin B12. And we can't go into that because that's a different story. But just remember, every vegan vegetarian should supplement vitamin B12. You might not show up the deficiency for 3 months. You might not show it up for decades. But when it comes, it can do 5 things to destroy your health. Okay, now we're going to look at the amino acids in wheat. Well, what was that tall spike there? What did we say that was? That was glutamine. Now I can see why a person that looks at this said, you know, why would the Indians up in the Punjab, why would they eat wheat for the chapatis and the other things that are made out of wheat? Why would they eat wheat for one of their principles that they eat of their food? They eat wheat, and they eat, well, what's the bean type that they eat? Dal or lentils. And those people are really strong and healthy up there. So there must be something wrong with the idea that that's a poor food to eat, the wheat is. You see how it's deficient in so many things, it looks like. Now it gives the idea that the protein quality is poor, but it isn't. Let's look at this. Why do they use the term poor quality? That's a poor protein. Wheat is a poor protein. All the plant foods are poor proteins. Why do they say that? Because they're not the same as human albumin or the albumin in the egg white. So now we've got a protein molecule here, and we're going to, these aren't all 20 piles of different amino acids, but we have these here, and we're going to start over and we're going to build another building. And so here we go. This is all schematic. And now we've got our protein molecule. Was the quality of those bricks, was there something wrong with those amino acids? Were they kind of misshapen or something? No, not at all. They were perfect. But it looks like we're deficient in some of these ones here, so we're going to have to wait for another shipment to come in. And so that's going to be a low protein diet. Is that going to be so that the person is going to be protein malnourished? Not at all. What happens when we have the high protein diet? Especially when it comes from animal products. You need to read the China study to be convinced maybe, but that gives us problems when we eat the high protein diet from the animal sources. Now let's take a look at something here. People will say, look, you must have seen this over in Africa. These little kids that run around and they're just as skinny as a stick. Or they have this, what we call kwashiorkor. They look like they're fat and healthy, but their hair isn't a good color. It looks like it's bleached out, and they're so unhealthy. It looks like that their skin is just, their body is just swollen up until the skin is just popped. And that's called kwashiorkor. And it does account for a lot of deaths. What's the problem there? Was it their diet? Why are they that way? It's because of their sanitation. Some of these children, by the time they're 2 years of age, they've had diarrhea with blood in it maybe 5 times. And they can't get that from their food to keep overcoming all this diarrhea that sends the blood out. And so that's the reason why they have that. Now, sometimes it is true, but sometimes there's ethnic cleansing, and we're not going to get into that, where certain groups that are in control are starving people to death. You see, some of those pictures are from that, but the other pictures where there's plenty of food around and these children are dying, it's because they're dying from the diarrhea with blood in it. So it's not because of the problem that way. The Chinese girls, the rural Chinese girls, have their first menstruation at 14 to 17 years of age. How about our American girls? When I went to medical school, the pediatrician there, she said, we're really concerned about this. This was clear back in the early 1970s. She said, you know, every 10 years, every decade, our little girls here are having their first menstruations 6 months earlier. Well, fortunately, it didn't just keep going, but some little girls are turning into puberty when they're 7. They're already starting to have breast development at 7 years of age. Can you imagine the emotional trauma that they go through when they have this happening? They start their menstruation at between 9 and 11 years of age. Well, you can say, well, they're maturing faster, they do well, they're so much better than they used to be. But let's take a look at that. American girls on high protein diets have their first menstruation between 9 and 11 years of age. This increases the risk of breast and female organ cancers. And we find that especially with the animal products. And that's the China study. Read it if you know somebody that has cancer. Now here we have the amino acids in corn plus beans. Now that looks pretty good, doesn't it? We aren't too deficient in anything, but what they've done is they've taken that spike and put it way at the top of the glutamine, okay? And so now we're going to shove it down, and we see that actually that combination, like the people in southern Africa and in Mexico and other places are eating, it's a perfectly healthy combination. You know, when I was in Africa, I was there for 15 years and I only saw 2 people with a heart attack. In the 15 years, I only saw 2 people that had cancer of the colon. And cancer of the breast in men was as much as, I saw as many cancer of the breast in men as I did in women. Pretty weird, isn't it? In America, we only have about 400 men that develop cancer of the breast a year. And some of them die from cancer of the breast. You may not have known that men get cancer of the breast. But for women, that was the #1 killer in America, was cancer of the breast. But now smoking, lung cancer, has edged out cancer of the breast in about the last 10 years. Now here we're going to see they took a whole lot of mice that were born at the same time, and they said, we're going to give them just one food to eat. You're only going to have one. So if you decide that you're only going to eat one food for the rest of your life, it probably shouldn't be lima beans. Or I would say it shouldn't be those organically grown snowpack peas. That's the ones that they're probably quite similar. Okay, so we see gluten is a high protein, lentils, green peas was higher. You see the peanut meal, and here's milk. But what was better than milk? Well, it was soy. What was better than soy? Casein. What is casein? Just the protein out of milk. Okay, so it was just the protein, and that was the highest. Okay, now let's take a look. Whoops. I'm getting so many things here. Somebody's going to have to help me probably. There we go. Now let's look at the next slide here. Remember how high gluten was in wheat? Well, they said, well, let's take the gluten, and that's from the grain, and we're going to add some L-lysine, okay? We'll put that in there. We'll get that from one of the legumes, and then we'll take the gluten and we'll add just a tiny bit of L-lysine to it, and look what it did. It was the same as soy. Soy was pretty good, wasn't it? Okay, so they said, let's take soy in the limiting factor. Let's put just a tiny bit, 0.2% of DL-methionine to it. And what did soy do when it had that limiting amino acid that it didn't have enough of? Remember, this one was the highest one before, wasn't it? And now soy, with the limiting amount of methionine, when that was added, then we see that was a very good growth there. So they said, well, let's just take the gluten and let's just give them lentils. We see that when they had the legume and they had the gluten from the grain, they got a very good growth curve there. Now this is just a slide that says a drop in scientific estimates of protein needs. This was 1860, and this is when they started out with 120 grams of protein, and then we realized that was too much, and then they've come down here in 1968, and then they've come down and down and down, and so we see that the ideal protein is down here. When this nutritionist told us about it, he was down at Loma Linda University, and he taught in the School of Public Health. What is it now that they tell us? They say that you should have 0.8 grams of protein per kilogram. And he said, really, it was only 1/3 of a gram. Remember I said that? And so we said, well, why did they say this? Actually, probably nobody says this anymore. But why did they say this when it was really only 1/3 of a gram? He said, well, I guess he was in on the discussion. They said, well, look, if we tell them when we've been telling them it's a whole gram, and we tell them it's only 1/3 of a gram, then people will be confused and they won't believe us. So let's tell them it's 0.8 grams. So actually, it's only 1/3. And so where are you going to get your calcium? When we talk about bones and groans and osteoporosis, we're going to talk about where you get it. But you'll get it from your green leafy vegetables, the way most of the world does. They can't assimilate, they can't digest milk. They're not used to it. Okay, now this is something that people that were creationists, and I'm one of them, that's the reason why a lot of people just think that the Bible story in the first 11 chapters of Genesis is just a story. You can't go by it because it had people living more than 800 years, more than 900 years. And they say, well, that's just a story because we know that men are living longer now than they did before. But according to the Bible account, and there's a lot of intelligent people that believe that the Bible is right, they had these long living, but then after the flood, meat had to be added to the diet. Why? Why did we have to have meat added to the diet? Well, because there's some places where you can't grow a big garden, right? The people that are up in the Arctic Circle, they've been eating the Atkins diet for hundreds of years, right? They've got problems too because of it. There's other things besides that. The climate was changed in a lot of different things, but now we see that today people live shorter lives, and we can't go into all that. But you realize that the life expectancy in the United States has gone up? I heard that just 2 weeks ago. For women, the life expectancy is 88 years. And for men, the life expectancy is 86 years. Now, I'm not sure about the quality of life in some of the people that are that old, that are in some of the places that are in retirement areas. But we want you to have a wonderful quality of life, okay? Now, here's the last slide. Were we to have the plant-based proteins and the whole world fed with the plant-based proteins, we would be able to solve world hunger. If we look at this, 10 pounds of plant protein, we give it to the human and they get 10 pounds of protein. We have the 10 pounds that goes into the cattle, and they get the 10 pounds of protein. If we take the milk, we've taken that and we've diluted it out now, so we're only getting 2.6 pounds of protein. If we eat the meat itself, we're only getting 1 pound of protein from that 10 pounds of corn or the protein that the animal was eating. Now the problem is that the Chinese are wanting to eat more like the Americans. They think that that's really good. And we're cutting down our rainforests in the Amazon basin and other places so that we can take all this beef and send it over there. And Africa's has grown a lot of beef to send it up to Europe during the mad cow disease. Times when that was really high in the news. So folks, what did we learn? You cannot get protein malnourished from eating a good, balanced, plant-based diet. And as you eat that, you will get the amino acids in the ratio that your body needs, and not the ones that are too much in the areas you don't need, so that they send more work to the kidneys. Thank you very much.